For 55 years, humanity's absolute farthest reach into deep space was the accidental byproduct of a life-or-death crisis. In April 1970, an oxygen tank exploded inside the Apollo 13 spacecraft. The crew's scheduled lunar landing at Fra-Mauro was immediately canceled. The mission instantly pivoted from scientific discovery to pure survival. Astronauts James Lovell, Jack Swigert, and Fred Hayes were forced to use their fragile lunar module as a makeshift lifeboat. With limited power and supplies, ground engineers improvised a free return trajectory. They used the moon's gravity to catch the crippled spacecraft and slingshot it toward home. That emergency maneuver had an unintended consequence. It carried the crew exactly 248,655 miles away from Earth. Because of this, our historical baseline for deep space was cemented in trauma. Traveling 250,000 miles away became synonymous with a fight for survival, rather than a sustainable way to do science. That boundary finally moved in April 2026. NASA launched Artemis II, marking the first time in half a century that humans intentionally headed back into deep space. Aboard the Orion capsule were 4 astronauts: Commander Reed Wiseman, Victor Glover, Christina Koch, and Canadian astronaut Jeremy Hansen. Their mission was designed to use the exact same deep space geometry as Apollo 13. They wouldn't touch down on the lunar surface, but they would fly completely around the moon's far side. Instead of shivering in a freezing, underpowered lifeboat, this crew spent their time deliberately stressing a fully powered spacecraft. They tested Orion's environmental life support systems and its ability to shield them from high-level cosmic radiation. By taking the exact same orbital path that nearly killed the Apollo 13 crew, Artemis II proved that humans can actually thrive in the outer limits of Earth's reach. Executing a flight plan this complex requires an immense international apparatus, drawing resources from NASA, the European Space Agency, and the Canadian Space Agency. All of that telemetry routes directly into the modern Mission Control Center, coordinating thousands of data points every second. And the people running those consoles are a new generation of engineers who have taken over for the Apollo veterans. Many of these critical roles are filled by young professionals from the American Midwest. Engineers like Jack Seeleman work as propulsion systems flight controllers. His specific job is to monitor and stress test the engines, ensuring there is absolutely no repeat of a 1970s hardware failure. At the same time, specialists like Alex Brewer oversee the complex software nodes that manage spacecraft navigation far beyond the safety of Earth's magnetic field. At 250,000 miles away, emergency rescue is physically impossible. Every drop of water, every line of code, and every engine burn has to execute flawlessly. Nailing this coordination between ground control and the spacecraft was the final, non-negotiable exam before anyone attempts to walk on the moon again. 6 days into the flight, while the Orion spacecraft was moving out of communication range behind the moon, it quietly crossed the invisible boundary set by Apollo 13. This chart shows the ultimate reach of both missions, with Artemis II pushing past the old high water mark to hit a maximum distance of 252,756 miles from Earth, setting a new human spaceflight record. From that vantage point, the crew witnessed a deep space solar eclipse, watching the moon completely block the sun while the Earth glowed in the darkness. They also received a message recorded by Apollo 13 commander Jim Lovell shortly before his death in 2025. Lovell welcomed the Artemis II crew to his old neighborhood, formally passing the torch to a new generation of explorers. Passing that 55-year-old marker shifted the trajectory of deep space exploration. Artemis II turned an emergency distance into a repeatable, high-precision flight path. But the Artemis program isn't stopping there. Returning to the moon is not the final destination. The flight data gathered during this mission directly informs the construction of the Lunar Gateway, which will serve as humanity's first orbital space station around the moon. Paired with new surface habitats, the Gateway will act as a permanent, sustainable base of operations for international science and commercial partners. Once this lunar infrastructure is fully tested and operational, space agencies will use it as the launching pad to send human crews to Mars. Breaking this distance record provides the data needed to push beyond the Earth-Moon system. Artemis II verified the navigation and life support systems required for missions that will eventually reach toward Mars.